electric resistance. So electrons flow through a material, they experience resistance to their flow, and it would depend, this resistance would depend on the types of material. There would be three types, and these are terms you've probably heard before. I could have, there's conductors, there are insulators, and there are what are sometimes called semiconductors, which are often used in electronics. So conductors let electrons to move relatively freely, so R would be small. Insulators, R is very large, and in semiconductors we're looking at intermediate values. German physicist named Ohm, he discovered that the amount of current that flowed through a conductor is proportional to the electric potential that is lost. So that means that if I double the potential difference, I should get double the current. If I triple the potential difference, I should get triple the current. This means that's my proportional sign, yes? Proportional to. If I replace this, it means that V is equal to I divided by V divided by I equals a constant, yes, and this constant varies from material to material. We call it the resistance of the material. Resistance is measured in ohms. V equals IR is just another way to write it. This is Ohm's law. We measure resistance using an ohm meter. Okay. Now, for us in electric circuits, usually there's going to be more than one resistor present, and because of this, we often want to turn all the little resistors into one super resistor, and we can connect resistors in two different ways, and in previous science courses maybe you've seen this before. I can connect them in series, and series means there's only one path from the first one to the next one. Now here I have three resistors in series, or I could just have two resistors. I could have four resistors, it doesn't matter. But when things are in series, there's only one path that is followed through those resistors. So here I'm turning R1, R2, and R3 into one super equivalent EQ, equivalent resistor. And if I wanted to do that, I'm not really that interested in a proof. You can find proofs online, but all I would do when they're in series is I add them together. So in this case, let's just say that this was 3, 4 ohms, 3 ohms, and 5 ohms. In this case, it would be 7, and this would be 12 ohms. Okay. Now, the other way to connect resistors is to connect them in parallel, which means that there's different paths for the electricity to flow, the electrons to flow. So I can go this way, I can go this way, or I can go a long way around. And to combine all these into one super resistor, an equivalent resistor, I use this formula right here. Okay. So let's try this. Let's say that this is 3 ohms, 4 ohms, and 12 ohms. So I would use this formula. I would say 1 over R is equal to 1 over 3 plus 1 over 4 plus 1 over 12. And I'm not going to use a calculator because I picked these numbers so that they're nice. I'm just going to find a common denominator. So 4 over 12 plus 3 over 12 plus 1 over 12 is 8 over 12. Now, 1 over R is 8 over 12, and this is something that students always forget to do. I'm not interested in what 1 over R is, I'm interested in what R is, and R is therefore 12 over 8, which is 3 halves. So the equivalent resistance of a 3, a 4, and a 12 is 3 halves. Note this is much smaller than any of these individually. And the reason is that there's more paths. Yes, there's more paths for the electricity to flow through. So we'll try a couple of examples here. Forget the kila, the K, this is 1,000, 1,000, 1,000, 2,000. Let's just use 1, 2. So which is often when they're more complicated scenarios, I have to do it in a number of steps. And I'm not, what I have to ask myself is, which ones will I add first? Well, I can't add this and this because I've got a break in between them. And I can't add this and this because there's no loop. When I look at which two can I combine first, these two are in series with each other. There's nothing happening in between, right? So I'm going to turn this into, so I got this guy, I got that guy, I got that guy, I got that guy, and I want to turn this and this when they're in series. I just add them. So this is a 2, a 2, a 2, a 1, and a 1. Right? Then what ones will I add next? Oh, these guys are parallel to each other. There's nothing else in between, so I'm gonna add those in parallel. Note that I can't add all 3 of these in parallel because this guy is kind of messing that up. This guy, and this guy. Yes. So this is 1, 1, 2, 2, and 2. So let's calculate that out. 1 over r for this guy right here is 1 over 2 plus 1 over 2, which is 1. So it looks like when I flip that, r is going to be 1 ohm. This is 1 ohm. Let's what ones will I add now? Oh, looks like these two guys right here are in series with each other. So I'm going to rewrite the rest. The stuff I'm not touching, that's a 1 and a 2. Yes. And I'm going to combine these 2 resistors into just one resistor. They're in series with each other. 1 plus 1 is 2. Now these two are parallel to each other. So I'm going to get that stays the same. Yes, this is still 1. This guy right here is 1 over r equals 1 over 2 plus 1 over 2, which is 1. So it looks like this guy, even when I inverse it to get r, it looks like this is 1 ohm also. 1 ohm, 1 ohm. And those two guys are in series with each other. So it looks like when I turn all of these resistors into just one super resistor, I should get a resistance of 2 ohms. I'll do one other. When I look at this, I could add these two. They're in series with each other. There's no splits. Yes. So I got battery here. 3 ohm, 3 ohm. Looks like I'm going to get one that's 6 ohms. Yes. Now I've got 2 here, nothing in between. These guys are parallel to each other. 2 ohms, 2 ohms. I just did a calculation like that a second ago. Yes. And 1 and 1. So let's do these calculations. These two are parallel. 1 over r equals 1 over 2 plus 1 over 2, which is gets me an r of 1, yes? So this is going to be 1 ohm. And this guy right here, 1 over r equals 1 over 1 plus 1 over 1, which is 2, yes? And therefore, 1 over, and therefore when I flip this to find r, I flip this and I get a half. So this guy is going to be a half ohm. Now what I'm left with is 3 resistors in series with each other, and when I turn those into one super resistor, 6, 7.5. Yes? Perfect. So that's how I add resistors together, and you'll be able to practice some of your problem-solving skills trying some of these questions for yourself.